Okay, students, now we will discuss about a very interesting topic, that is optics. So this is very interesting and it has every moment it has an application to our day-to-day life. So let us discuss or start about the topic optics. So as what is this optics? We can say the branch of physics. It is the branch of physics which deals with the study of the nature and the propagation of light. So optics is the branch of physics which deals with light, nature and propagation of light. Nature and the propagation of light. That is your optics. Clear? Then, which is the branch of physics? Which this optics, and it deals with the light. Then the question is, what is light? What is a light? So what is light? What is light? What you can say about light? We can say light is the form of energy. It is a form of energy which produces the sensation of sight. The sensation of sight. I see an object because of light. How? If I see an object, if I see this object, light comes from a source incident on this body and it is reflected from this body to my eye and in the retina. Then I can see the object, this object. Means light incident on the object and reflect to my eye, then I can see the object. Means it gives me the sensation of sight. If I close my eyes, I cannot able to see the object. So we can say that the form of energy, light is the form of energy. It is the form of energy. It is the form of energy which produces sensation of sight in us. The sensation of sight in us. Clear? Now, the next thing is that. So this is about light, and we will deal in optics. We will deal a form of energy which gives or which produces the sensation of sight in our day-to-day life. That we will deal in your optics. But this definition of light, we can say this is partial, because when we read further, then we can define light more precise way, that we will discuss later. But now come to the topic that optics, it deals with light, but the optics, this branch of physics, optics, is a very vast topic. So because of a vast topic, and the optics is broadly divided into two branches. One is the ray optics and the other one is the wave optics. This optics is again divided ray optics and wave optics. This ray optics and wave optics, why it is divided? Because according to the nature of light, the assumption of what is the nature of light with that assumption, light can be considered as a ray, and also the light can be considered as a wave. If we consider the light is a ray, then the different phenomena occurs by light. By considering that as a ray, that we will deal in ray optics. Means in ray optics we will consider the light as a ray. The light as a ray. And in wave optics we consider the light is a wave, and we will discuss the different phenomena associated. Clear? Means the phenomena like reflection of light, refraction of light, that we can consider and we can explain by considering light as a ray. But the phenomena like interference, diffraction, in that phenomena we cannot say light is a ray, we have to say that light is a wave. Then we can explain this phenomena, the wave optics. Clear? So ray optics is the branch of optics which analysis different optical phenomena by considering light as a ray. So in ray optics we consider light as a ray. In wave optics we consider light as a wave, and by considering this light as a wave we will consider different phenomena. Okay, like here in ray optics we will discuss about the phenomena like reflection, refraction. By considering the wave optics, here we will consider interference, the phenomena of light, interference, diffraction, that we will discuss in wave optics. Clear? So initially first we will discuss about ray optics, where we consider light as a ray and the phenomena like reflection, diffraction that can be analyzed. In wave optics we consider light as a wave and the phenomena like interference, diffraction that we will discuss or analyze. These are the phenomena shown by light. Okay. So now we will go to the first topic is your. In the first we will discuss about ray optics. First we will discuss about ray optics, and from that first we will discuss about ray optics. Now come to more the division of optics, that is your ray optics. Now in this ray optics, before we start this ray optics, there are some terms generally associated with light. When we discuss about light in optics, generally when we discuss about optics, there are some terms comes in optics. These are the regular terms or these are the common terms. Like all of you know, always in optics you will come a word called as a source. What is this source? What do you mean by a source? We can say a body or an object which emits light in all directions. In all directions. And a body which emits light in all directions. A body which emits light in all directions. So a body which emits light in all directions is called as a source. Now the source can be a luminous and non-luminous source. So the source can be luminous and it can be non-luminous. So I can say the source can be luminous and it can be non-luminous. The source can be luminous and it can be non-luminous. So what is the luminous source? Now the question, what is the luminous source? The source which produces light of its own in all directions. In all directions. Okay. So the source which produces light of its own. The source which produces light of its own, and the source about the non-luminous, the source which produces light, the source which produces light only when light from other source, only when light from other source incident on it. Incident on it. Okay. So the source which produces light only when light from other source incident on it. Means we can say non-luminous source is the source which has no light of its own. It has no light of its own. So now you can say the luminous source. What are the examples of luminous source? The best example is your sun. That is your stars. Examples you can say stars, candle, the candle light, right? And the electric ball. These are the examples of your luminous source. But non-luminous source which produces light only when light from other source incident on it, no light of its own. And what are the examples of non-luminous? Like your earth, moon, right? And what are we finding in our body, a duster, etc. These are the non-luminous. Source. So this is about a source, and already you know about the concept of this luminous and the non-luminous. Okay. So these are the terms generally comes in our optics. Then come to the after the source. So after knowing the source can be a luminous source or from a non-luminous source. That we know from the definition and the statement of source. Then comes to your medium. What is the medium? What do you mean by the medium? In optics, what do you mean by the medium? The substance through which light propagates or tends to propagate, means it tries to propagate. Then that is called the medium. So the substance through which light propagates or tends to propagate. The medium, the substance through which light propagates or tends to propagate, it's called as a medium. Right? And the medium can be a transparent and maybe a translucent or maybe a opaque medium. Okay, so the medium can be transparent, maybe a translucent, or maybe a opaque medium. The medium may be transparent, translucent, or may be opaque. So what is a transparent? The medium is called as a transparent medium. When the medium through which light can pass easily. The medium through which light can pass easily. That is a transparent. Like your glass, the light bulb. From that light bulb, the light can pass. And like your thermometer. Okay. So we can say the transparent medium. The medium through which light can pass easily. The medium through which light can pass easily. Clear? And examples are glass, bulb, electric bulb, etc. You know the examples, you write more examples, etc. Translucent. The medium through which light pass partially. The medium through which light pass partially. Medium through which light pass partially. The light pass partially means the total light cannot pass through the medium. Some light pass through the medium, the rest gets other phenomena we will discuss. Okay. So the light passes partially. That is called as a translucent. Examples are your tracing paper. You have seen the tracing papers. Examples you can say tracing paper. The tracing papers, we are using the tracing paper, they are translucent. Then frosted glass. You have seen these glasses, frosted glass, etc. Clear? These are the translucent and the frosted glass, tracing paper, these are the translucent. And what is an opaque? So the opaque is the medium through which light cannot pass is called as opaque. The medium through which light cannot pass. The medium through which light cannot pass is called as a opaque medium. And what are the examples of opaque medium? Your wood, light cannot pass through the wood, and the others are like you can write order for your a duster, a chalk. This can be a medium. So a chalk, etc. They are opaque medium. Clear? Now comes to that. After knowing this medium, source and medium, then we will go to another definition, that is your ray. What is to mean by a ray? Because in ray optics we are dealing with ray optics. What is a ray? Here we will discuss what is a ray. First, what is a ray? You should know the definition of ray. A straight line path along which light travels. A straight line path along which light travels in a straight line in the homogeneous medium. The medium should not be any breakage. It should be a homogeneous medium. Then that is called as a ray. So we can say a straight line path along which light travels in a medium. Light travels in a homogeneous medium. You can say in a homogeneous medium is called as a ray. A straight line path along which light travels in a homogeneous medium is called as a ray. And the ray can be represented by an arrow mark. This represents the direction of propagation of the light, and it is represented by arrow mark. So this is the representation. You can say if it is drawn This is the representation of a ray. A ray is represented by a arrow mark. The arrow points in the direction of propagation of light. Suppose I am propagating like this, so the light is traveling like this. So that is the representation of a ray. Okay? Then comes your beam. What is the beam? Beam means what? We can say beam, a number of rays combined together. A number of rays combined together. A number of rays combined together is called as a beam. A number of rays means there are so many number of rays combined together, like this is called as a beam. Or it may be like this. So this is combined together is called as a beam. And individual is a ray. A number of rays combined together is called as a beam. Similarly, you can get another definition, that is a beam, a collection of beam is called as also a pencil. A number of or a collection of beam is called as a pencil. Okay. Then comes to your beam. The beams can be a convergent beam, divergent beam, and a parallel beam. So the beam can be a convergent beam, or maybe a divergent beam, or maybe a parallel beam. The beam can be a convergent, divergent, and parallel beam. So what is a convergent beam? A narrow beam of rays, in which width of that beam goes on decreasing as the ray proceeds forward. In convergent, the convergent beam is what? A narrow beam of rays, convergent beam, a narrow beam of rays, in which the width of it goes on decreasing. Width of rays goes on decreasing as the ray proceed forward. Proceed forward. Remember, a narrow beam of rays in which the width of it goes on decreasing as the ray proceeds forward. Means it converges. Means we can say like this. This is the forward. The ray is proceeding and the width goes on decreasing. So that is a convergent beam. As you proceed forward, then the width goes on decreasing. Or we can say like this. As you proceed in this direction, the width goes on decreasing. Right? So that is the convergent. Then we will go to the divergent. Here we can say a narrow beam of rays in which the width, or in which the rays meet at a point when we proceed in backward of propagation of the rays. Backward in the propagation of rays. Or we can say it is a narrow beam of rays in which the rays meet at a point, then when we proceed in the backward, of propagation of rays. The rays, a narrow beam of rays in which the rays meet at a point when we proceed in the backward of the propagation of rays. Propagation of rays means what? Just the suppose the rays are proceeding like this. Clear? Now the rays are proceeding like this. So when we proceed, the rays are traveling like this. But when we proceed in the back, they meet at a point. This is a divergent. This is a ray, this is a ray. When we move along the propagation, the width goes on increasing. You can say the width goes on increasing. I am defining different way. But other way, when we proceed in the backward, means this is the backward of propagation of ray. The ray is propagation this direction. If I proceed backward, this is the direction backward. They meet at a point. Then that is called as a divergent beam. So we can say the divergent beam means, we can say the divergent is like this. So these are the divergent. When we proceed in the backward, they meet at a point. Or the width, when we proceed along the propagation of ray, the width goes on increasing. So that is a divergent beam. Then next is the, what is a parallel beam. So the parallel beam is the narrow beam of rays in which all the rays move parallel to each other. The rays move parallel to each other. The rays move parallel to each other. The rays move parallel to each other, and the width of the beam does not change, which cannot be changed, or that width will remain same. So the rays move parallel to each other. So we can show like this. This is a parallel beam of rays. Clear? So dear students, these are some definitions that we should come across in our optics, that is the ray optics, or you can say that is also in a wave optics. These are the definitions generally we should know before we proceed in optics. Now come to the most important part is your one of the phenomenon of light in ray optics, where we consider the light as a ray. One of the most important, the reflection. That is the reflection of light. That is the reflection of light. What is the most important factor? That is the reflection of light. So, what do you mean by the reflection of light? So, the phenomenon of returning back of light from the boundary of a medium, into the same medium. The phenomenon of returning back of light, the phenomenon of returning back of light from the boundary of a medium. The phenomenon of returning back of light from the boundary of a medium or an object, or from a surface, light from the boundary of a medium or from a surface into the same medium, is called reflection. Means in reflection, the light sent back to the same medium. It is the phenomenon of sent back the light to the same medium from a surface or from a boundary. That surface or boundary is called as the reflecting surface. That surface or boundary is called as the reflecting surface. So this is the boundary of a medium, or you can say this is the reflecting surface. From the reflecting surface. Clear? So this is the reflection. And remember one thing, the reflection can occur in both a smooth surface and a rough surface. So now the question is that some reflection can occur from a smooth surface or a rough surface. So now the question comes in your mind, what the smooth surface and in a rough surface. So in a smooth surface you can say the surface variation is comparable to the wavelength of incident light. That is the smooth surface. So as you have not discussed in detail about the wavelength, all these things. So for a smooth surface you can say if parallel rays of light are incident on the surface and they reflect back to the same medium, again parallel, then that surface is called as a what? A smooth surface. When the reflected means on the smooth surface, if the parallel rays incident, so this is the rays, the parallel rays incident and they reflect. They reflect parallel. Again they reflect parallel. Then this surface is called as a smooth surface. This surface is called as a smooth surface. And in rough surface, this is the surface suppose, and these are the parallel rays incident. Parallel rays incident on the surface, but reflect in different. They are not parallel. If these are the reflected, means the rays sent back, that is the reflected. They are not parallel. Incident parallel, but reflected is not parallel. Reflected rays are not parallel. Then it is called as a rough surface. And if the reflection occurs on the smooth surface, then you can see the image of the object that we will discuss later. Okay. So this is about the reflection. Now we come to the another topic, that is the from this reflection. So as you know, the reflection means it is the phenomenon of sending back light into the same medium from a boundary or from an object, that is called as the reflecting surface. Then we will go to the reflection, in the reflection of light, how this happens and what are the terms in the reflection of light, right? So in this case, what we represent like this line, this is called as a reflecting surface. So let me write all these things here. So this is called as a reflecting surface. So this is the reflecting surface, or that is, we can say, that is the representation of a plane mirror. You can say one side is coated, other side is reflected, right? Transparent. This side is coated. So that is the representation of a reflecting surface. Okay. Now then, so this is, you can say, a normal N O and S. They are normal on the reflecting surface. This is called as the normal on the reflecting surface. NO and S, this is the normal on the reflecting surface. Clear? Next, then the other thing is that this is a ray incident on the reflecting surface, AO. So AO is called as the incident ray. AO is called as the incident ray. When the ray AO incident, now this is a reflecting surface. So that it is the phenomenon of sending back light in the same medium. So this is the same medium. This may be another medium or whatever may be. You don't know about this medium, but this is the same medium. So we can reflect like this, OB. So we can say OB is the reflected ray. OB is the reflected ray. It is the right. So then next, another step. This angle I I is the angle of incidence. Angle of incidence. What is that angle of incidence? It is the angle between the incident ray and the normal. This is the normal NO. Normal to the reflecting surface at the point of incidence. This angle is called as your angle of incidence. At that point of incidence, I have drawn this normal. So this is the incident ray. So this angle is called angle of incidence. Similarly, this angle is called as angle of reflection. R is called, remember, angle of reflection because it is reflection. So R is called angle of reflection. Angle between the reflected ray and the normal is called as the normal to the reflecting surface is called as your angle of reflection. Clear? Then next another one is your the angle between the incident ray to the reflecting surface or angle between the reflected ray to the reflecting surface. These are called as alpha. Both are same. We will discuss why they are same. Alpha is called as the glancing angle. This is called as your glancing. That alpha is called as a glancing angle or glazing angle, or you can say this is your. Oh, let me draw this one. Glancing angle or glazing angle. Alpha is called glancing angle, or this is also called as your glazing angle. What is that glancing angle? The angle between the incident ray and the reflecting surface, or reflected ray and the reflecting surface. So angle between the incident ray or reflected ray with the reflecting surface is called as your glancing angle or glazing angle. Then the next is the delta. What is the delta? So let us say this is the incident ray, actual path of incident ray. Remember, I am showing that in another color. So this is the incident ray AO, and this is the, if there is no reflection, the ray will travel along this path. It will go like this because light travels in a straight line in a medium, in a homogeneous medium. So this is the rectilinear propagation of light. This is also called rectilinear propagation of light. It travels in a straight line. So AO is incident. If there is no reflecting surface, it will travel along this direction. Now the ray travels along this path, but because of this reflecting surface, it will travel along OB. So this angle is called as the delta. Delta is called as your angle of deviation. Delta is called angle of deviation. Delta is called angle of deviation. Right? So it is the angle between the reflected ray max with the reflected ray max with the line of action. Line of action of incident ray. Remember, angle of deviation is the angle between the reflected ray and the line of action of incident ray. The incident ray is not actually traveling along this path. It is reflected back because it is reflection. But if the ray travels along this is the line of action of the incident ray, then this angle is called deviated. Means the concept is, what do you mean by deviated? I am deviating from my path. My actual path is along this direction, but I get deviated. Right? So that's the actual path and deviated. This is the deviated. So this angle is called as your actual path to deviated path is called as your angle of deviation. Now, so this is about the reflection. So remember this figure. After the discussing, we will find an expression here also in reflection. But now we will go to the most important thing. Another is your laws of reflection of light. Next we will go to the laws of reflection of light. Okay, or laws of reflection. The most important one is the laws of reflection. So what are the laws of reflection? First, there are two laws. One, what is the first law? The two laws. One is the the incident ray, reflected ray, and the normal, at the point of incidence, on reflecting surface, all lie on the same plane, all lie in the same plane, and the plane is perpendicular to the reflecting surface, and the plane is perpendicular to the reflecting surface. The incident ray, this is the reflecting surface, incident ray, reflected ray, normal, these are normal at the point of incidence on the reflecting surface, all these lie in the same plane. Incident ray, normal at the point of incidence on the reflecting surface, reflected ray, all lie in the same plane, and this plane is perpendicular to the reflecting surface. This is my reflecting surface. This is the reflecting surface. Incident ray, reflected ray, normal, all lie in this plane, and this plane is perpendicular to the reflecting surface. This is the first, and the second one is the angle of incidence. The angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. Means this is the angle of incidence, angle between incident ray and normal, and this is the angle of reflection, incident ray and reflected ray. So this says angle of incidence I is equal to angle of reflection R. This is very, very important thing. Okay. Now from here we will show for a expression for this deviation angle. Here from this figure, from the same figure I will derive. So these are the laws of reflection. We go through these laws of reflection. Now from here, let me derive a relation here. From these laws of reflection, let me go to this figure. Again I am repeating the thing that this is your I R. So according to this laws of reflection, angle of incidence equal to angle of reflection. And what is about these angles? These are called, what is alpha? Incident ray with reflecting surface or reflected ray with this is called what? Glancing angle. This is called as your glancing angle or glazing angle. And what is this about? This is the line of action of the incident ray, and this angle is called as your delta. This angle is called as your delta, angle of deviation, right? So now come to this point that from these figures you can say alpha plus I is equal to 90 degree, or alpha plus R is also 90 degree, because I is equal to R, angle of incidence equal to angle of reflection. So I am writing this in terms of angles. Don't take that angle symbol is not there, means I am writing in an angle form, right? This is the one factor. So we can say the glancing angle alpha is always 90 minus I or 90 minus R. That is the one factor. Always the glancing angle is 90 minus angle of incidence. Next, another part for delta. So now you see delta plus R plus I, this total angle, delta plus R plus I, this angle, this total. What is this? 180. Delta plus I plus R, 180 degree. Delta plus I plus R, both are same, so I can write 2I or 2R, 180. or delta is equal to 180 minus 2i, or I can write delta is equal to 180 minus 2r. This is the formula for angle of deviation, which I derived from the laws of reflection. Here, next we will go to the another thing, that the reflection from a plane mirror. Now we will go to the reflection in a plane mirror and how the image is formed by a plane mirror. That we have to discuss. So now you remember one thing, then I will go to this optics part. Remember, when you find the image of an object, always remember, you have to take two incident rays from the object and do the reflection by the reflecting surface and find where they meet or appears to meet. That point or that is the image of the object. Let me explain this. If I draw, then you can understand. Remember one thing, when you trace, when you find, or when you want to find the image of an object, always remember you have to take at least two rays from the object and do the phenomenon of reflection and trace or join the lines may meet or appears to meet. Then that will be the image of an object. Okay. So here we will go to the image formation by a, I can say this is the image formation by a plane mirror. I can write image formation by a plane mirror. All of you are using this plane mirror. Every day you are using this plane mirror and you are looking through this plane mirror and you are seeing your image in the plane mirror. So now this is the most important thing, how we trace this plane mirror. So how we draw the ray diagram. Now we go to the very important thing, that is your how to draw the image formation. Remember, this is very simple one, that's why I have drawn first. So this is a plane mirror, representation of the plane mirror. This line means this is the opaque side and this is the transparent, that is the brush. Okay. Now draw a normal. Okay. Before you draw this normal, let us consider there is an object O. An object O. There is an object O is at this point. O is an object. So now I want to find the image formed by this object. So what I will do here? First thing, I will trace two lines, two incident rays. First, let me trace this. A ray from the object incident normally on the reflecting surface. Incident ray normally on the reflecting surface. Is that clear? One ray incident normally on the reflecting surface. So if this is the normally on the incident surface, what is the incident ray for this incident ray? When you find the incident angle, then what you will do? You should draw a normal at the point of incidence. So this is the normal. This is the normal. If this is the same normal and on that normal line the incident ray is there, then what is the angle there? 0 degree. So angle of incidence is 0. So what will be angle of reflection? That will also 0. Means the ray will send back along the same path like this. So this is the incident ray and this is the reflected ray. It reflects the same. So here what we know from this one? From this, if a ray is normally on a reflecting surface, it will retrace on the same path. It will go in the same path. Number one. Next, number two, take the another ray from that object. Right? Take another ray from the object which incident obliquely with some angle. So this is another incident. Number two. This is the first incident ray. Then this is the second incident. Obliquely with some angle. So if it incident obliquely, then what you will do? To know the incident angle, I have to draw a normal at the point of incidence. So this is my angle of incidence I. If this is the angle of incidence I, then according to the laws of reflection, the ray will reflect with the same angle I is equal to R. That is the reflected ray will look like that. So we can show that is the reflected ray like this is the reflected ray. Suppose R. So I is equal to R. So this is the reflected ray. So this is the incident ray and this is the reflected. So I got two reflected ray. Two reflected ray for two incident ray. One is along this path, the other one is along this path. Now, when you see from this side, when you see the image, you will see the image on this side. I will see through this plane mirror on this side. When I see from this side, when I look on this side, these two reflected rays appears to come from a point. How? Now you see this. I will draw this one. How it looks? This is I. So when you see from this side, you find that the two reflected ray appears to come from this I. They appears to come. If the word comes, they actually not come from I. They appears to come from I. They appears means my eye cannot distinguish. I will see only the rays, and the rays are appears to come, or my sensation is that I feel that these two reflected rays they may come from a point, and that point is your eye. The eye is below this mirror. So this is the image of the object O. Remember, this is the image of the object O. Okay. So this is the method of drawing the or tracing the what? Reflection by a plane mirror or image formation by a plane mirror. So O is the object and I is the image. So you can give the names also. Here OA, B, okay, and this is suppose your M dash, right? So these are the reflecting surface, incident ray, reflected ray. One incident ray incident normally reflect back. This reflected ray they appears to come from the point. Clear? So this is the image form. So when the ray appears to come, then some of the properties involved here. Remember the properties of image formation. What are the properties? Remember here, for a plane mirror, the image formed by a plane mirror, what are the properties are that? Object distance, remember always, object distance means is equal to image distance for a plane mirror. Means if this is the object distance u, means from the reflecting surface to the object. So this is called as your object distance u. And from the reflecting surface to the image, this is called d, that is called image distance. So object distance is always is equal to image distance. And remember, in optics we will use sign convention. So sign convention means if this reflecting surface is a reference line. This reflecting surface is a reference line. If you go up, positive. If you go below, like your coordinate system. If you go along this positive y direction, this is the negative y direction. So generally you write u is equal to minus d. This minus sign don't get confused. It is for sign convention. We will discuss here. Or you can write u plus b is equal to 0. Object distance plus image distance is equal to 0. Means the simple thing is that if I stand 15 cm in front, away from in front of a plane mirror, then I will find my image 15 cm behind the mirror. That is the case in a plane mirror. Clear? So the image is like this. Next, another one is that image is virtual. This image is a virtual image. Why? Because these two reflected rays does not meet anywhere. These two reflected rays does not meet anywhere on this side, on the reflecting side. They appears to come from I. They appears. That's why the image is virtual. The image is virtual. And remember, the image always is erect. If I stand like this in front of the plane mirror, I will find my image like erect. My head is this side, leg is on this side, so that is called erect. If I place the pen like this in front of the plane mirror, I will find the image like the same. It is called erect. If this is the object, and if I find the image on the plane mirror like this, then that is, you can say that inverted, but we will always get a erect image. The image is a erect image, right? And another most important thing is that there is no magnification, means there is no change in size of the object. There is no magnification, so we can say magnification in a plane mirror is 1. Magnification is 1, means size of the image equal to size of the object. You can say size of image is equal to size of object. In a plane mirror, remember, magnification is 1 means size of image equal to size of object. So if you divide these two, size of image by size of object, that is the definition of magnification. What type of magnification? That is called linear magnification. Remember, linear magnification. Size of image by size of object is called linear magnification, and that is always 1 for a plane mirror. Okay. Then the image, the most important thing is that the image is laterally inverted. Image is, in a plane mirror, the image is laterally inverted. What do you mean by this lateral inversion? Lateral inversion means what? When you stand in front of the mirror, you find your left side appears on the right and right appears on the left. That is called laterally inversion or laterally inverted. So these are the so many other are there. Then other factors are there on the other properties are there on the image formation by a plane mirror. There are so many properties are there. We will not go in detail. And the main points what is required I have discussed in the image formation by a plane mirror. Clear? And the other properties are also there. Don't go in detail. The main important thing is that, dear students, for this year you don't have the topic this what we discuss here, that is not in your syllabus, but to know the optics more clearly or to know the optics, this is must, we should, or this is very very important to know or to go further in ray optics, or you can say in optics. So that's where, that's for we have discussed these things. Okay, thank you.